So we're going to start talking about how to combine polynomials. And today we're specifically going to look at just adding and subtracting polynomials. So before we actually add or subtract them, there are a few vocabulary words that I just want to go over with you guys to make sure that when you are reading the questions, you know what's happening. So you've probably seen these words before, but we have a monomial and a polynomial. A monomial is going to be a number or a variable or a product of a number and a variable, but it's just one single term. So we could say it's one number or one variable, or it can be a product, which remember product just means we're multiplying, so all these things have to be connected. So it can be or a product of a number and a variable. So these are things, monomials are things that look like 10. That would be our number. We could say 3x, which would be a product of a number. We could even say 1/2 a b squared. So it can have exponents. It can have more than one letter. It's just going to be all connected together. It's one term. So we can't add, we can't subtract, we can't divide. We can only multiply. So our monomials only have one term. And that's what mono stands for, one. So these all have one term. Whereas a polynomial is a sum of monomials. So we can add or subtract a bunch of monomials together, and that gives us a polynomial. So this is a sum of monomials. And these are things you're used to seeing. These are our expressions that we've been working with. They can be things like 3x plus 5, where I'm adding or I'm subtracting two things. I could also have things like 4x squared minus 2x plus 1. And anytime I'm writing a polynomial, I always want to write the things with the biggest exponents first, and I kind of want to decrease the order of my exponents from biggest to smallest as I write it. That's called the standard form, and we'll look a little bit more at that as we move on in the lesson. Things that are not considered a polynomial, not a polynomial would be things that have division in them. So if we had like x squared divided by x plus 1, or if I had a negative exponent. So if I had like 3x to the negative fifth, that negative exponent makes it not a polynomial. So we can have exponents, but they have to be positive. We can add and subtract with polynomials, and we can multiply, but we can't divide, and we can't have negative exponents. So we're only going to be looking at things that are polynomials when we're adding and subtracting, but some of the first questions that we're going to look at in the notes today are just going to ask us to decide if it's even a polynomial, if we could even add and subtract it together. So far, so good? Okay. So when we're talking about a polynomial or we're talking about a monomial, I was saying before we like to write it in order of the biggest exponent to the smallest exponent. So when we're talking about the exponents, we have a fancy math word called the degree. and the degree is just going to be the sum of the exponents in each term, and it's going to be the biggest sum. So if we were looking at a polynomial, we would look at each exponent, and whichever the biggest exponent is, that's going to be our degree. So sometimes they might ask us to describe a polynomial based on the degree, and as you get further in your math career, you'll see that the degree kind of changes the shape of the graph and gives you an idea of what the graph is going to look like before you actually start to graph it. So we want to just be able to pick out the degree today, and the degree is just the largest sum of exponents in one term. So we don't want to add up all the exponents to get to the degree. We want to look at each term, add up the exponents in a term, and remember when I'm talking about a term, I'm saying anything that's connected to each other. Like this polynomial has 3 terms because they're separated by addition and subtraction signs. The terms are the things that are connected to each other. So if I wanted to, for example, find the degree of 4x squared minus 2x plus 1, I want to look at each term, add up all the exponents that I have, and see which one is the biggest sum, and then that's going to be my degree. So if I'm looking at my exponents, my first term has an exponent of 2. My second term doesn't have an exponent there, but we know that we don't have to write an exponent if it's just 1. So there's really an imaginary 1 right here after that x. We just don't write it because we know that it's already there. And then my last term is just a 1. It's just a number. There are no x's. So when there are no x's, that's as if we were saying x to the 0 power because there are 0 x's there. So then I just want to go through and I want to look at each term and I want to add up all the exponents that I have. In this situation, there isn't anything to add because I only have one variable in each term. So all I have to say is, okay, my sum of my exponents here is just 2. My exponents here, 1. My exponents here, 0. So since 2 is my biggest sum of exponents, my degree is 2. So if you're looking at a polynomial that's written like we're used to, where it just has x's, or maybe it just has one variable y, you're just going to pick out the biggest exponent. We could also have things like find the degree of 2ab cubed plus b. So those are things that don't look as normal as we're used to. They have 2 variables in it. They also have an exponent of 3. But we can find that degree by adding up all the exponents in each term. So this is what I was talking about, where we have to pay attention and we're actually going to have to add things. So I'm going to have to take the exponent from the a and the exponent from the b to get the degree for that term. So I take the imaginary 1 that's there, and I do 1 plus 3, which gives me 4. Here, I just have b to the first power. I know that 4 is bigger than 1, so my degree here is 4. That's as tricky as that can get. So in addition to picking out the degree, once we've picked out the degree, another way that we can help kind of understand the shape of the graph and what's happening with the equation a little bit better is to pick out what's called the leading coefficient. And all the leading coefficient is saying it's the coefficient in the term with the degree. So coefficient, and remember coefficient is just the number in front of the variables. So it's the number in front of the variables. It's a coefficient in the term with the degree. So if we're looking at our first example of 4x squared minus 2x plus x, we already said that our degree is 2, that our biggest exponent there was 2. So our leading coefficient is just the coefficient that's in that term, the number in front of the variable there. So here we could say the leading coefficient is 4. In our second example, where we had 2ab cubed plus b, we knew our degree came from a and b cubed because it added up to be 4. So that means our leading coefficient is going to be the number in front of those variables. So it's just going to be the 2 here. So leading coefficient is just like a really big fancy word for pick out the number in front of the variables with the biggest exponent. How do you feel about this so far? Okay. What if I gave you these and asked you to pick out the degree and the leading coefficient? We've got 5x squared, negative 1/2 xy cubed, and negative 3. They want the degree and the leading coefficient for each one. So if we look at this first one, if we look at A where it says 5x squared, we notice it's a monomial because there's no addition or subtraction. So I'm just looking for the sum of the exponents in that term. So I'm just looking to add up all the exponents that are right there in that one term because there are no other terms. And I see right off the bat there's only one exponent. It's a 2. There's nothing for me to add. So my degree has to be 2. There's only one term there that has an exponent, so my leading coefficient has to be the number out in front of the variable, so 5. B is a little bit trickier because now I have 2 variables, so I have to add up all the exponents from all the variables. So I see first, I just have an x, which we know is really the first power. Then I have a 3, so my degree is 1 plus 3, which is 4. My leading coefficient is the number out in front, so it's going to be that negative 1/2. The last one is probably, it's in the most simple form, but it seems the trickiest because you kind of panic because there's no variables and you think, what the heck is going on here? I don't know what to do. But there's no variables because in reality, right here, all I have is an x to the 0 or a y to the 0. I don't have any variables, right? I have 0 variables. So that means my degree is 0. It also means that the only number that they gave me was -3, which is my leading coefficient. So sometimes when it's super simplified like that, it looks a little crazier than it actually is, and you just got to kind of trust your gut like that. There are no variables, so there can't be any exponents, which means the degree is 0. And then the only number they gave you, the -3, has to be the leading coefficient because it's the only number there. What about if I gave you some polynomials and asked you to write them in standard form? So if I had given you 15x minus x cubed plus 3 and asked you to write it in standard form, it's just a fancy way of saying put the terms in order from the biggest exponent to the smallest exponent. So standard form is just biggest to smallest exponent, and this just helps us organize our work so it's easier for other people to read. It kind of gives us a standard of how we show our work so that we can compare it easily to other people when we're working. So all we want to do is we want to go through and we want to take each term and put the one with the biggest exponent first, the one with the smallest exponent last. The thing you have to remember is when you're taking these and rearranging it, whatever sign is in front of the term has to stay with it. So when I'm looking at this, I'm going to have a 15x. The negative sign is going to stay with the x cubed, and the plus sign is going to stay with the 3. So when I rearrange them, I keep the sign that's in front of them with the term. So I'm going to take, the first one I'm going to take is my negative x cubed because it has the biggest exponent. So I'm going to say, okay, I have negative x cubed. Then the next term is this 15x. Since it doesn't have a sign, I know it's positive, so I'm going to use a plus sign. 15x. And my last term is always going to be the constant, because the constant we know has a degree of 0, so that's got to come last. So when I'm rearranging them or writing things in standard form, I just want to make sure my exponents are in order from biggest to smallest, which if I go back and check, I see that I have 3, 1, 0, so I'm in standard form. This is my final answer for A. If I was looking at B, I've got 4 plus 5x squared minus x. So I've got a 4, I've got a positive 5x squared, and a negative x. So I see an exponent of 2. I know that one's going to come first. Since it's a positive 5x squared, I don't have to write the plus sign in front of it. Right? We don't normally write things when they're positive. We just write the number down. So I don't need the plus sign there. I can just write 5x squared. Then I've got a minus x. And then I've got just a 4. So I don't want to just write the 4 at the end like that because, first of all, it looks weird. And if they're side by side like that, it's telling me to multiply. Because it's a positive 4, I have to make sure I put that plus sign in between the x and the 4. Even though it wasn't there in the original one, I need to make sure that I separate all those terms with addition signs and subtraction signs. All right, we got a little bit more, and then you guys will be ready to do your murder mystery classwork. So now that we know a lot about polynomials, we can actually add them together. When we're adding polynomials together, we can only add like terms. So we have to remind ourselves that we can only add like terms, and like terms have to have the same variable and the same exponent. So when we're adding things together, they have to have the same variable, same exponent. So the first thing we want to look at is, okay, each of these has an x. So all our variables are the same. That's good. We're not looking for different variables. But we can only combine terms that have the same exponent. So if I'm looking at this first term, this 2x cubed, there's nothing else in the equation or in the expression that they give us that has an x to the third power. There's no other x cubes, so there's nothing I can do with that first term. I'm just going to bring it straight down and rewrite it. There's nothing I can add together with it, so I'm just going to leave it. Then I see, okay, now I have a negative 5x squared. And over here, I have a 2x squared. So I'm going to take the negative 5x squared and the positive 2x squared, and I'm going to put them next to each other since they're like terms, and that'll make it a little bit easier for me to go in and simplify once I'm done. Then I'm going to look my next variable. I have a positive x, and over here I have a positive x. So when I'm rewriting this, I want to bring both of my positive x's down together. And then lastly, I have this negative 1. There's nothing for me to do with that negative 1. There's no other, just plain numbers. There's no other constants. So the same thing, like the 2x cubed, I'm just going to bring this back down because I don't want to lose it. But there's nothing for me to really combine it with. So now that I've put the things that are together next to each other, the like terms together, I'm just going to go through and actually collect my like terms and simplify it. So I'm going to bring down the 2x cubed. Then I'm going to say to myself, okay, negative 5x squared plus negative 2x squared. If I had negative 5 and I add 2 more, I end up with negative 3x squared. Negative x, or a positive x, plus another x. Gives us positive 2x. And then bring down my minus 1. So once I've combined everything that's similar, that's my final answer. So you're not going to get answers like we're used to of like x equals 1 or a coordinate. We're going to actually get big, long polynomials as our answer when we're doing this. You're just combining the like terms. With the second one, I'm going to show you a different method you can use in order to combine your like terms. It kind of looks like, it reminds me of the elimination where you stack them on top of each other and add them together. So in order to do the second one, I'm going to take this first 3x squared plus x minus 6, and I'm going to rewrite it. Now I have to make sure when I'm doing this that I have every exponent in order counting down. So I have here a 2, a 1, and a 0, so I'm okay. If I had missed an exponent, I have to leave a space and just kind of skip over it. So then I'm going to take my second equation, the x squared, the 4x, and the 10, and I'm going to make sure that when I do that, when I rewrite it underneath it, the x squareds are lined up together, the regular x's are lined up, and the numbers are lined up. Because now all I'm going to do because I'm going to add these straight down like I would have added numbers back in the day. And I'm just going to go, okay, 3x squared plus x squared gives me 4x squared. X plus 4x gives me a positive 5x. Negative 6 plus 10 gives me positive 4, which is my final answer. And I can always check to make sure that this is my final answer by making sure that all my exponents are different in every term. If you have any exponents that are the same, those are like terms, so then you can go back and combine that more or simplify that farther. Do you like one of the methods better than the other one? Yeah? Okay. So I want to show you one with subtraction, and then you guys will be free to start your classwork, okay? So if we're subtracting, the biggest difference is that you have a minus sign in between the two polynomials instead of an addition sign. You can do the same thing that you were doing with addition if you just bring the negative and distribute it to everything. So if I take this negative sign and I distribute it into every term in the second, then I can just add them together the way I was. So if I take my 4n squared plus 5, and then I do negative times negative 2n squared, I'm going to get positive 2n squared. A negative times a positive 2n gives me negative 2n, and a negative times negative 4 gives me positive 4. It really just switches the signs of everything that's in the second term, or in the second polynomial. And then I can just go through and collect my like terms. So I can say, okay, 4n squared and 2n squared. So I have a 4n squared plus a 2n squared. Then I just have 1 negative 2n, and I have a positive 5 and a positive 4. So then when I collect my like terms, 4n squared plus 2n squared gives me 6n squared. The negative 2n doesn't have anything to collect it with or combine it with. And then a positive 5 plus 4 gives me 9. So even though they were asking me to find the difference or they were asking me to subtract them, once I distribute that negative sign, I'm doing exactly the same thing I was doing before. I'm still just combining my like terms. So again, I'm going to do the same thing with the second one. I'm just going to stack them on top of each other. So I'm going to take the 4x squared minus 3x plus 5 and the 3x squared minus x minus 8. And if I'm going to subtract them, I know that when I put a big subtraction sign here, it's going to change every sign. So this first one's going to become negative, this is going to become positive, and this is going to become positive. And then I can just say to myself, okay, 4x squared minus 3x squared gives me x squared. Negative 3x plus x gives me negative 2x. And 5 plus 8 gives me 13. So your classwork today is going to be a murder mystery, and the murder mystery has 10 clues for you. In order to simplify the clues, you're going to have to add or subtract the polynomials, and your answer will be one of the options. It's like a multiple choice, basically. Your answer should match one of the multiple choice options, which is going to help you eliminate suspects and figure out where the crime took place and who the final suspect was. Okay?